video, we discussed about sequences and patterns. So for today, I am your teacher, Ma'am Christine, and I will be discussing about arithmetic sequence. So our objectives for today, at the end of the lesson, the students are expected to first, illustrate an arithmetic sequence. Second, find the next few terms of an arithmetic sequence. And lastly, find the general or the end term of an arithmetic sequence. How do we determine whether the given sequence is arithmetic or not? Let's try to explore. I have here three examples of an arithmetic sequence. In the last video, you discussed about the terms of a sequence, which are a sub 1, a sub 2, a sub 3, and so on until a sub n. So in these examples, let's try to get the differences of a sub 2 and a sub 1, a sub 3 and a sub 2, and so on. Now let us try number 1. Our a sub 2 is 10, and our a sub 1 is 3. So 10 minus 3, that is positive 7. Our a sub 3 is 17, and our a sub 2 is 10. So 17 minus 10, that is positive 7. Our a sub 4 is 24, and our a sub 3 is 17. So let's get the difference. 24 minus 17, that is positive 7. And on the second example, our a sub 2 is 15, and our a sub 1 is 20. So that getting the difference, that is 15 minus 20. Take note that 20 is bigger than 15. So our difference would be negative. So 15 minus 20, that is negative 5. Next, 10 minus 15, that would be negative 5. And lastly, 5 minus 10, that is negative 5 also. For the third example, we have a sub 2 is negative 3 and a sub 1 is 1. So negative 3 minus 1, the same sign, so we need to add 3 plus 1, that is 4. Copy the sign, negative. So negative 3 minus 1 is negative 4. Next, a sub 3 is negative 7 and a sub 2 is negative 3. So negative 7 minus negative 3, so that would be negative 7 plus 3. So negative 7 plus 3, that is negative 4. Lastly, negative 12 minus negative 7, that would be negative 12 plus 7. Answer is negative 4. So what can you say about the differences that we got on the three arithmetic sequences? The differences are the same. Now let us try to define what is an arithmetic sequence. So an arithmetic sequence is a sequence in which the consecutive terms have a common difference. The sequence a sub 1, a sub 2, a sub 3 until a sub n is arithmetic if there is a number d such that a sub 2 minus a sub 1 is b, a sub 3 minus a sub 2 is b, and a sub 4 minus a sub 3 is d, and so on. The number d is the common difference in the arithmetic sequence. Now let us get the two examples earlier. 3, 10, 17, and 24. The common difference is 7. Now let us use the term common difference to describe the 7 that we got earlier. Another example, 20, 15, 10, and 5. Yung nakuha natin kanina ay negative 5. So, ang common difference niya ay negative 5. From this also, we can conclude something. So, if the common difference, d is positive, the terms in the arithmetic sequence are arranged in increasing or ascending order. So, ibig sabihin, kapag positive ang ating common difference, ang terms natin ay increasing or pataas. While, if the common difference d is negative, the terms in the arithmetic sequence are arranged in decreasing or descending order. So, Ibig sabihin nito, kapag negative ang ating D or common difference, ang terms natin ay decreasing or pababa. Determining whether a sequence is arithmetic or not. Let us have our first example. 45, 43, 41, 39, and 37. What we need to do is to get the difference. And if all the difference are the same, that means the given sequence is arithmetic. While if the difference are not the same, it means that the sequence is not arithmetic. Let's start. 43 minus 45, that is negative 2. 41 minus 43, that is negative 2. 39 minus 41, that is negative 2. And lastly, 37 minus 39, that is negative 2. Meron ba siyang common difference? Meron. So, ang common difference niya ay D equals negative 2. Ibig sabihin, ang sequence na ito ay arithmetic sequence. Now, for the next example, 1, 2, 4, 8, 16, 32, and 64. Let us get the difference. 2 minus 1, 1. 4 minus 2, 2. 8 minus 4, 4. 16 minus 8, 8. 32 minus 16, 16. 64 minus 32 is 32. Meron ba siyang common difference? Wala. So, ibig sabihin, ang sequence na ito ay hindi siya arithmetic sequence. Now, try to answer the following. Determine whether the sequence is arithmetic or not. Please pause the video while you are answering and play again when you are done. Now, let us check. For number 3, our given is 1, 1, 2, 3, 5, 8, and 13. Let us get the difference. 1 minus 1 is 0. 2 minus 1 is 1. Kailangan pa ba natin siyang ituloy? Hindi na. Ibig sabihin, kapag magkaiba na ang nakuha natin na difference, wala siyang common difference. So, ang number 3 natin ay hindi arithmetic sequence, or not an arithmetic sequence. For number 4, our given is negative 8, negative 4, 0, 4, 8, 12, and 16. Getting the difference, negative 4 minus negative 8, negative 4 plus 8 na siya. So, 4. 0 minus negative 4, magiging na siyang 0 plus 4. So, that is 4. 4 minus 0 is 4. 8 minus 4, 4. 12 minus 8 is 4. And lastly, 16 minus 12 is 4. Meron ba siyang common difference? Meron. D is equal to 4. Ibig sabihin, ang sequence natin sa number 4 ay arithmetic sequence. Now, for number 5, meron tayong fractions. Now, let us get the difference. 5 halves minus 2, that is also the same as 2 and 1 half minus 2. So, 1 half. Next, 3 minus 5 halves, or 3 minus 2 and 1 half, that is 1 half. 7 halves minus 3, that is the same as 3 and 1 half minus 3, that is 1 half. So 4 minus 7 half, that is the same as 4 minus 3 and 1 half, that is 1 half. So for number 5, our D is 1 half. That means number 5 is an arithmetic sequence. Finding the next few terms of an arithmetic sequence. Let's try this. Carla deposited 500 in a savings account on her daughter's first birthday, 1,000 on her second birthday, and 1,500 on her third birthday. She continued this pattern until her daughter's seventh birthday. How much money would Carla have deposited on her daughter's seventh birthday? So let us show this problem in a table. So we have first, second, third, fourth, until seventh birthday. And on the first birthday, she deposited 500. On the second birthday, she deposited 1,000. While on the third, she deposited 1,500. So based on the concept of arithmetic sequence, we have our a sub 1 is 500, our a sub 2 is 1,000, our a sub 3 is 1,500, and we need to find a sub 4 until a sub 7. Now let us observe the first three terms of the sequence, 500, 1,000, and 1,500. Ano yung ina-add na number para makuha yung sunod na term? Nag-a-add ng 500. So, 500 plus 500, that is 1,000. Sunod, 1,000 plus 500, that is 1,500. So, paano natin makukuha ang sunod? Kailangan lang din mag-add ng 500. So, 1,500 plus 500, that is 2,000. 2,000 plus 500, that is 2,500. 2,500 plus 500, that is 3,000. And lastly, 3,000 plus 500, that is 3,500. So, how much money did she deposit on her daughter's 7th birthday? Carla has deposited 3,500 on her daughter's 7th birthday. So, kapag ang hinihingi lang naman next few terms ng sequence, kailangan niya lang malaman kung ano yung ina-add na difference or common difference sa first few terms ng sequence. Solving for the unknown using the formula for a sub. In arithmetic sequence, the general term is given by the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, d is the common difference, and n is the number of terms. Example, for number 1, our given a sub 1 is equal to 3, d is equal to 6, and n is equal to 10. We need to find the a sub 10 or the 10th term. So using the formula, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Again, take note, huwag kakalimutan ang formula ng arithmetic sequence, which is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Now what we need to do is just substitute the givens. So, our n is 10, so that would be a sub 10. Our a sub 1 is 3, and our d is 6. Now, we need to simplify the parentheses. So, 10 minus 1, that is 9. We now have 3 plus 9 times 6. By MDAS, we need to solve first 9 times 6. So, 9 times 6, that is 54. Plus 3, so our a sub 10 is 57. This means that the 10th term of the given is 57. For the next example, given a sub 1 is equal to 21, d is equal to 3, and a sub n is equal to 72. We need to find the n, or the number of terms. So using the same formula, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Let us first substitute the given. Our a sub n is 72. Our a sub 1 is 21. And our d is 3. So the missing term here is the n, or the number of terms. Let's simplify first. Distribute 3. So 72 equals to 21 plus 3 times n, that is 3n. 3 times negative 1 is equal to negative 3. Now we need to transpose the numerical coefficients to the right. So that would be 72 minus 21 plus 3 is equal to 3n. Simplify 72 minus 21 plus 3. That would be 54. So 54 is equal to 3n. To get the value of n, we need to divide both sides by 3. So 3n divided by 3 is n. 54 divided by 3 is 18. So in the given in number 2, our number of terms is 18. Next, finding the first 5 terms given the general term. So for our example, the general term is a sub n is equal to 2 times n plus 3. So to get the first 5 terms, we need to substitute 1, 2, 3, 4, and 5 to the value of n. Let's start with n equals 1. So a sub 1 is equal to 2 times substitute n by 1. 2 times 1 plus 3. So 2 times 1 is 2 plus 3. Our a sub 1 is 5. Next, n is equal to 2. Our a sub 2 would be 2 times 2 plus 3. So 2 times 2 is 4 plus 3 is 7. So our a sub 2 would be 7. Next, for n equals 3, our a sub 3 is equal to 2 times 3 plus 3. So 2 times 3, that is 6, plus 3 is equal to 9. So our a sub 3 would be 9. For n equals 4, our a sub 4 would be 2 times 4 plus 3. So 2 times 4, that is 8, plus 3 is equal to 11. So our a sub 4 would be 11. For the last one, n is equal to 5. Our a sub 5 would be 2 times 5 plus 3. 2 times 5 is 10, plus 3 is equal to 13. So our a sub 5 would be 13. So therefore, the first 5 terms of the sequence are 5, 7, 9, 11, and 13. Now answer the following. Find the first 5 terms of the sequence given the general term. We have here 2 examples. Please pause the video while you are answering and play again when you're done. Let us check. For number 2, a sub n is equal to 3n plus 1. Let's try first with n is equal to 1. So a sub 1 would be 3 times 1 plus 1. So that is 4. For n is equal to 2, our a sub 2 would be 3 times 2 plus 1. So that is 7. For n is equal to 3, our a sub 3 would be 3 times 3 plus 1. So that is 10. For n is equal to 4, our a sub 4 would be 3 times 4 plus 1. That is 13. For the last one, our n is equal to 5. So a sub 5 is equal to 3 times 5 plus 1. That is 16. Therefore, the first 5 terms of the sequence are 4, 7, 10, 13, and 16. For the next example, a sub n is equal to 5n minus 2. Let's start with n is equal to 1. Our a sub 1 would be 5 times 1 minus 2. That is 3. For n is equal to 2, our a sub 2 would be 5 times 2 minus 2. So that is 8. For n is equal to 3, our a sub 3 is equal to 5 times 3 minus 2. That is 13. For n is equal to 4, our a sub 4 would be 5 times 4 minus 2, so that is 18. For the last one, our a sub 5 is equal to 5 times 5 minus 2, that is 23. Therefore, the first 5 terms of the sequence are 3, 8, 13, 18, and 23. Finding the general term given the first few terms of an arithmetic sequence. So given the arithmetic sequence 5, 11, 17, 23, and 29, we need to find the general term. So using the formula, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Let us get the given from the given arithmetic sequence. Our a sub 1 would be 5 since 5 is the first term. While d, we can get it by subtracting the consecutive terms. So you can choose any two consecutive terms in the given sequence. Let us choose 11 and 5. 11 minus 5 is 6. So our common difference is 6. Let's just substitute a sub 1 and d on the formula. So a sub n is equal to a sub 1 is 5 plus, we will not replace the n, so that will remain the quantity n minus 1. Then substitute the d, that would be 6. Let's simplify. Distribute 6, so that would be 5 plus 6 times n, that is 6n. 6 times negative 1, that is negative 6. Now we just need to combine similar terms. 5 minus 6, that is negative 1. So a sub n is equal to 6n minus 1. So the general term for the sequence 5, 11, 17, 23, and 29 is a sub n equals 6n minus 1. Now try this yourself. Find the general term given the first few terms of the sequence. Please pause the video while you are answering and play again when you're done. Let us check. For the given number 2, 54, 50, 46, 42, and 38. So using the formula, a sub n is equal to a sub 1 times the quantity n minus 1 times d. Let us identify a sub 1. Our first term is 54. While the common difference is 50 minus 54, that is negative 4. Let's substitute the given to the formula. A sub n is equal to a sub 1 is 54 and d is negative 4. So 54 plus the quantity n minus 1 times negative 4. So distribute. Negative 4 times n, that is negative 4n. Negative 4 times negative 1, that is positive 4. Combining similar terms, 54 plus 4, that is 58. So our a sub n would be negative 4n plus 58. Therefore, the general term for the given sequence is a sub n is equal to negative 4n plus 58. Now let us try the next number. Negative 7, negative 2, 3, 8, 13, and 18. So using the formula, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Let us identify the given. The first term is negative 7. So our a sub 1 would be negative 7. While for the d, we can use any consecutive term. So let us get 8 and 3. So 8 minus 3, that is 5. So our common difference is 5. Now let us use the formula. Substitute the given that we got. A sub 1 is negative 7 plus the quantity n minus 1 times our d is 5. Now let's simplify. Distribute 5. So negative 7 plus 5 times n is 5n. And 5 times negative 1 is negative 5. Combining similar terms. So negative 5 minus 7, that is negative 12. So our a sub n would be 5n minus 12. So the general term for the sequence is a sub n is equal to 5n minus 12. Now let's go to the last part of the lesson for today. Solving word problems. Our first problem. The conference hall has 33 rows of seats. The last row contains 80 seats. Each row has two fewer seats than the row behind it. How many seats are there in the first row? Now first, let us identify the given. What do you think would be the value of n? Our n here is the number of rows. So, how many rows are there? 33. So, our n is equal to 33. While the d, that is, the keyword is two fewer seats than the row behind it. So, our d is equal to 2. While our last term or last row is 86. So, that is a sub 33 is equal to 80. Now, let us use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. We just need to substitute the given that we got. So, our a sub 33, that is 80. Our a sub 1 is missing kasi yun ang hinahanap. How many seats are there in the first row? While our n is 33 and our d is 2. 33 minus 1, that is 32. Now have 80 is equal to a sub 1 plus 32 times 2. Let's get the product of this first. So 32 times 2, that is 64. Now transpose 64 to the other side. Or a sub 1 would be 80 minus 64. So simplify 80 minus 64, that is 60. This means that there are 16 seats in the first row. Now for the next problem, please try this one. The USI auditorium has 20 rows of seats. The last row contains 78 seats. Each row has 3 fewer seats than the row behind it. How many seats are there in the first row? Please pause the video while you are answering and play it again when you're done. Now let us try to answer. Let's identify the given first. How many rows are there? 20. So our n would be 20. While for the d, the keyword is 3. So d is equal to 3. And our a sub 20, since there are 20 rows, is 78. Now let's use the formula again. A sub 1 plus the quantity n minus 1 times d is equal to a sub 20. So substitute a sub 20 is 78, our n is 20, and our d is 3. Now we need to simplify first the numbers in the parentheses. So 20 minus 1, that is 19, and 19 times 3, that is 57. And we need to transpose 57. 78 minus 57, that is 21. So this means that there are 21 seats in the first. For STE students, please answer this problem for our enrichment activity. In this lesson, we use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. What you need to do is you need to find out how did we come up with this formula for the general term of an arithmetic sequence. You need to show your complete solutions for the derivation of the said formula. That's it. I hope you learned something today. And if you still have questions, please don't hesitate to ask your teacher. Also, don't forget to answer your assignment and make a short reflection about the topic for this module. Questions for assignment and reflection can be found at the end of the module. Thank you for listening, everyone.